This recording is to remind CJ interns how to run a t-test if that is what it's called for in your final paper. Now a t-test is appropriate when you have a dependent variable that's continuous in nature. You cannot do a crosstab or a chi-square with these variables because they're simply too difficult to interpret. So if you have a dependent variable that's continuous in nature, a t-test and a means comparison is the type of analysis you're going to want to do. For this demonstration, my research question is, does education impacts length of sentence? If you remember, this is the data set that we pulled into Excel. I have a variable for education and I have a variable for sentence length. Looking in the variable view, we see that my education variable, if you will remember, is measured 1 or coded 1 if the person has a high school diploma or more, and 0 if the person does not have a high school diploma. And my length of sentence is measured in months, and it ranges from 0 to 240. So that is essentially 0 to 20 years. Now, going back to my data view, it's time to run my t-test and my means comparison. To do this, I'll go to Analyze, Compare Means, Independent Samples t-test. I'm going to put my dependent variable, which is length of sentence in months, into the test variable box. And I'm going to put my grouping variable, which is education, into the grouping variable box. This is my independent variable. Now my independent variable is coded 0 and 1. If your independent variable is coded 1 and 2, you might need to put different numbers here. But I coded mine as 0 and 1. 0 indicates no high school diploma, 1 indicates high school diploma or more. Now the question I'm asking is education related to sentence in months? And specifically, is having more education related to having a lesser sentence in months? So my null hypothesis for this study is there's no relationship between education and length of sentence, and my alternate hypothesis is that there is a relationship between education and length of sentence, in that the more education one has, the lesser sentence they will receive. Now there are many reasons why this might be the case, and perhaps I've discussed them all in my literature review, but this is what's guiding and setting up my analysis right now. Now I'm going to hit OK, and SPSS is going to give us a very meaningful table, a very meaningful means comparison table. This is how you interpret a means comparison table. Right here, for everyone who did not have a high school diploma, their average length of sentence was 104 months. For everyone who had a high school diploma or higher, their average length of sentence was 57 months. Now this difference in means is quite large, 50 months. It's almost 4 years. So it certainly seems as though our variable of education makes a difference in sentence length. The question becomes, is this difference in means statistically significant? And to know that for sure, we have to look at the t-test table, which is below. Now this Levine's test for equality of variances, I don't want you to worry about too much. We're going to assume equal variances, and we're going to read from this top row of data. Our t for this analysis is 8.941, and our significance value is 0.000. That means our p is less than 0.001. What that tells me is that these findings, this difference in means, is statistically significant at the p is less than 0.001 level, and that means we can reject the null hypothesis that states that there is no relationship between education and sentence length. We find support that there is a relationship between education and sentence length, in that those with more education are likely to receive a lesser sentence than those without education. And we can reject the null hypothesis here with 99.9% confidence that that is the correct thing to do.